My name is Ted Hallum. I'm the Deputy Director of oLabs AI Center of Excellence. We're out at the makerspace where we're flying some drones and collecting footage to tweak our object detection models. So when you have modern machine learning models, they're essentially exquisite mathematical pattern detectors. When you train a model, you're literally just like you would a child. You're training your model on training data, which represent a snapshot in time. As long as the real world continues to exhibit patterns that are like that training data, the model performs well. Machine learning model drift is when you have new patterns emerging in the world that are foreign. These are alien patterns to the model. They're not encapsulated within the model's training data. As new observations flow in that don't look like any of the training examples, modern machine learning models will give you a prediction, but that prediction is going to be inaccurate. And the more different the new observation is from the original training examples, the more extreme the drift is going to be. The whole point of Hatteras is to help you first build your model, then get it deployed, and then to monitor your model in production to know when it appreciably starts to degrade. So just a hypothetical scenario. If you had a computer vision model that was designed to detect wolves, and all of a sudden you shifted to an environment with, say, 15 huskies, huskies are a visually similar creature to a wolf. And chances are, if all the model was trained on was pictures of wolves, you would get a detection. But what you would notice is the confidence level of that detection would go down because huskies are slightly different from wolves. And if you were to introduce other types of dogs that were even more different, because it was only initially trained on what wolves look like, you'd see again, probably still a detection of a dog-like object, but the confidence would be even lower. And the more objects that you introduce that were further and further away from the wolf, like let's say if you started introducing cats into the frame, then eventually the detections would just stop altogether. When it comes to model remediation, there really is no one-size-fits-all. Sometimes you have a model that's performing a basic task that's low gravity, and when drift's detected, you just want Hatteras to retrain the model on the new training examples that are available and quickly get the model redeployed with as little interaction as possible. In other cases that are more high gravity, more liability, you want more of a human in the loop. You want them to be presented with a range of options where they can specify when they want the retrain to occur, when they want the new model to be deployed to replace the old model, how long they want the two models to be deployed in tandem. The use cases are everywhere that machine learning is being used, because we're all using this paradigm of supervised machine learning where we're training our models on examples, and those examples are never going to be perfectly representative of every pattern that's going to emerge out indefinitely into the future. So whether you're doing computer vision for object detection, whether you're doing natural language processing for chatbots, it really doesn't matter. Any machine learning model that's based on supervised machine learning is going to be victim to drift and needs oLabs. They need Hatteras.